This is a typical architecture of the application load balancer. First, you will have the application load balancer configured in one of the availability zones. Then, you will have one or more listeners configured, which basically listens to the HTTP or HTTPS traffic on the defined port. The listeners evaluate one or more rules based on their priority and determines which rule to apply. You will be having one or more target groups defined which contain one or more targets inside them that will receive the traffic or the requests. The rules that I mentioned before will have the logic to decide which target group the traffic should go to. The application load balancer then monitors the health of these targets before forwarding the traffic to them. It only forwards the traffic to the healthy instances. Here, you need to remember that a target, which could be an EC2 instance or a container or just an IP address, can belong to multiple target groups. The rule does not care about the targets, it only cares about which target group to forward the traffic. The targets can be registered and deregistered to and from the target groups. So, in a nutshell, the workflow is that after receiving the traffic, the application load balancer evaluates the listener rules in priority order and determines which rule to apply. Of course, the rule with higher priority gets applied first. It then monitors the health of the registered targets and then selects only the healthy targets to forward the traffic to. The main components of an application load balancer, and in fact even of the network load balancer, are listeners, rules, health checks, and target groups. Let's see some of the important points about each of them. A listener basically checks for the connection request using a protocol and a port that you configure. For the application load balancers, the listeners would be for HTTP or HTTPS. The rules that you define for a listener determine how the load balancer routes requests to the targets. That is, the rules dictate the forwarding logic for the traffic. The listeners support the HTTP and HTTPS protocols and ports ranging from 1 to 65535. You need to configure SSL server certificate on application load balancer if the listener is configured for HTTPS. And the application load balancer supports the deployment of the SSL certificate on itself. The listeners provide native support for web sockets with both HTTP and HTTPS listeners and HTTP2 with only HTTPS listeners. Quite simply, rules determine where the traffic will be forwarded. Each listener has a default rule and additional rules can optionally be added. The default rule cannot have conditions and cannot be deleted. It can be modified but simply cannot be deleted. Something to keep in mind. The rules have a priority, one or more actions, an optional host condition, and an optional path condition. Rules have priorities, that is 1, 2, 3, etc., with lower number representing a higher priority. The conditions can be host-based conditions or path-based conditions, which is also called as path-based routing. We are going to see an example of path-based routing in our demonstration. There is also a provision for a fixed response action in rules. Health checks basically monitor the health of the registered targets so that the load balancer can send requests only to the healthy targets. Each target group has health checks configured. The health checks are performed on all targets registered to a register group that is specified in a listener rule of your load balancer. Attaching a target group to an auto-scaling group enables you to scale each service dynamically based on demand. Another important component of application load balancers are target and the target groups. What is a target? It is basically a resource to which the request get forwarded by the application load balancer. A target type could be an EC2 instance, a container, or IP addresses. Target group is used to route requests to one or more registered targets. So target group basically contains multiple target instances. When a rule condition is met, the traffic is forwarded to the corresponding target group. You can create different target groups for different types of requests. Elastic load balancing stops sending requests to targets that are in deregistering state. So, in order for the traffic to be routed, the targets in the target groups has to be in healthy and functioning state. There is a concept called a slow start mode which gives targets enough time to warm up before the load balancer sends them full share of their requests. Now let us see how an application load balancer works via demonstration. Note that this is an example of path-based routing. In this example, the objective is that when a user types the URL in their web browser, if the URL path contains /pictures, this word in it, it should route the traffic to EC2 instances which will display the message, for example, processing your images. And if the URL path contains /videos in it, it should route the traffic to the instances which will display the message, for example, processing your videos. For this, first we will configure two target groups, one for the images and one for the videos processing servers. The images target group will contain two EC2 instances that will process images, whereas the videos target group will contain two EC2 instances that will process the videos. We will also configure the suitable health checks for them. Then we will configure a listener for port 80 to listen to the HTTP traffic. We will configure two rules. First, if the URL contains the word /pictures, it will select the images target group and will forward the request to its registered EC2 instances. Similarly, if the URL contains the word /videos, it will select the videos target group and will forward the request to its registered EC2 instances. In the AWS console, let's go ahead and create our image processing and video processing servers. Go to EC2, click Launch Instance, select the Amazon Linux AMI, click Next. Just keep the settings as is. Now click on Advanced Details. Here we are going to use the user data section to set up our image processing web server. Now with this video, I have provided 4 scripts, 2 for the image processing servers and 2 for video processing servers. Open the one for the first image processing server, copy its content and paste it here. Click Next. Next. Let's name this server as Image Processing Server 1. Select the existing security group, which is WizLabs SG. Now here, you at least need to have the HTTP port and SSH port open for the incoming connections. Click Next and launch it. Select the key pair as EC2 key pair that we have been using so far and launch the instances. Now go back to the instances and launch our second image processing server. Here, copy the content from the image processing server 2 script and paste it. Now let's go ahead and launch our video processing servers in the similar fashion. Then launch the video processing server 2. Okay, we have our 2 image processing servers and 2 video processing servers ready. Let's see what our scripts are doing. In the image processing server 1 script, it is basically installing Apache. Then it is creating an index or a home page where it just puts the message saying that this is the home page of image processing server 1. And then it creates an images.html page where it just puts out a message saying that processing your images from server 1. Similarly, in the image server 2 script, it is going to put the message saying that this is the home page of image processing server 2, and in the images.html it is putting out a message saying that it is processing your images from server 2. And as you might have guessed, the videos processing server script will do the same, but instead the message will contain processing your videos from server 1 and processing your videos from server 2. This is a very simple script to understand. So in our example, we have already created the image processing and video processing servers. Now let's go ahead and create the target groups. Click on target groups under load balancing. Click create target group and give it a name tg/images. The protocol that it will use is HTTP, or you can also use HTTPS. But for that, you will need to apply the SSL certificate on the load balancer. But for our purpose, we'll stick to HTTP. Now it also has an option for the TCP protocol, but that target group will be used by the network load balancer, not the application load balancer. So for our demonstration purpose, just go ahead and select HTTP. The port that it will listen to is 80. The target type can be an instance or an IP address. We are going to use instance. In the health check settings, basically you will configure a protocol and a path for checking the health of the system. The protocol that can be used is HTTP or HTTPS. The path represents the path of, for example, an HTML file or any other file that the elastic load balancer will check if it exists on the instance. If it exists, then it will determine it as healthy. But if it doesn't, that target or that instance will be marked as unhealthy. With the /, it represents that it will check the index file on that instance, which will be the index.html in our case. Now this part of the advanced settings represents the total number of attempts that elastic load balancer should make before labeling the instances as healthy or unhealthy. So a healthy threshold basically represents total number of successive attempts from elastic load balancer to determine an unhealthy instance as healthy. So let's say you had an unhealthy instance, now that becomes a healthy instance, but to be marked it as a healthy, the elastic load balancer would make these number of attempts before it marks it as healthy. Similarly, this number represents the total number of successive attempts that elastic load balancer does by using this protocol and path to determine that instance as unhealthy before marking it as unhealthy. The timeout is the time given for the elastic load balancer to use this protocol and port to connect and determine as whether it is healthy or not. The interval basically represents the total number of time between the two attempts. And the success code of 200 is just a standard HTTP return code that determines that the instance is healthy or not. So overall, what elastic load balancer is going to do is it is going to attempt connecting to this instance via this protocol and path, and then it is going to make at least two attempts before marking the instance as unhealthy, and it is going to make at least 5 attempts before marking the unhealthy instance as healthy back again. The timeout and the interval settings are measured in terms of seconds. Now keep them as default and click create. Now in the description, note few things here. The protocol and port that we are using is HTTP and AT. The target type is instance. The load balancer field is empty at the moment because we have not associated this target group with any load balancer. Now click on targets, edit. Now we have 4 instances running, out of which we want to register the image processing servers with this target group. So select them and click on add registered so they get added to the registered target section. Click save. Now note here that for these instances, the status is unused. This is simply because this target group is not yet associated with any load balancer. This state will change later. But for now, let's go ahead and create a target group for our video server. Keep the protocol, port, and other settings as same. Click create. Select the videos target group and edit the targets. Here we are going to select only the video processing servers and we'll add them to the register targets. Now, as I had mentioned that a target can belong to multiple target groups depending on its functionality. For us, we want the video processing servers only to be part of this target group. So after registering, click on save. So in our example, we have created the target groups and have added our respective image processing and video processing servers. Now let's go ahead and configure our load balancer. So under load balancing, click on load balancers. Click create load balancer. Go ahead and create the application load balancer. Let's give it a name. Now the application load balancer can be internet facing, that is publicly accessible, or internally accessible. For us, it is going to be internet facing, so keep the scheme as is. The address type is IP version 4. The listener that we will be using is HTTP and the port is 80. Let's go ahead and select all the availability zones. You can add tags to this load balancer if you wish. I'm going to keep it as empty. Click next. Now select the security group for our web servers. Click next. Now here we need to associate the target group to this load balancer. So at this step also you can create a new target group or just associate the existing ones. Now one thing to note that is at this step you can only associate one target group with this load balancer. And that is fine. Just go ahead and select whichever you want. I'm going to select images. We are going to associate the videos target group later via the rules and listener. So just select target group images. Now these settings and the advanced health settings are copied over from the target group. You cannot override them here. Now click next. Review the registered targets, and these must be the image processing servers. Click Review and hit Create. At this moment, the state of this load balancer is provisioning. Now, while it is provisioning the load balancer, let's go back to our target groups. Click on the images target group and go to its description. Now you can see that the load balancer, the associated load balancer, is the content processing application load balancer. But if you click on videos, the load balancer is not yet associated. Now go back to the images target group and click on targets. And here you can see that the status of the instances is changed to initial. Now let's go back to the load balancers. Now by the time it is getting provisioned, let's go ahead and update the listeners. So under listener, we have a default rule that is created, which is forwarding the traffic to the target group images. Now click on view and edit rules. This is the section where you'll be configuring all your rules. The default rule is forwarding all the traffic to the target group images. Now let's go ahead and add some new rules. Click here, insert rule. The first rule that we are going to add, and let's go back to our example. The first rule is that if the URL path contains /pictures, then forward the request to the image processing server's target group. So let's go ahead and do that. Add condition. Here you can either have condition based on the host or the path. The host condition basically checks the host field of the header of the message of the HTTP traffic. But for now, let's select the path, and the path, just type */images. Now this particular field, it supports the regular expressions. That means if the URL contains any text prior to this word and any text after it, it is going to match this condition. In the action, select forward to target group images. Click OK and then save. Let's add our second rule. The condition is if the path contains /videos, then forward the traffic to the target group videos and save. Now on your left on the rules, you have priorities, and the lowest the number, the highest is the priority. Now our rules are actually mutually exclusive, so the priority here really does not matter, because all the videos related traffic is going to go to target group videos, and the traffic related to images is going to go to the target group images. But you can change the order using this option. Now here the default rule is going to be if the URL does not contain images or videos, it is going to go to the target group images. But if you go back to our script, what we have configured is that on the home page, it is going to display this message as this is the home page of image processing server. Whereas if the URL contains images.html, it is going to show the image as processing your images from server 1, etc. So with our settings, if our URL contains /images, you should see that message that processing the images. If the URL contains videos, it is going to show the message saying processing the videos. However, if it contains none of these two words, it is going to show that this is the home page of the image processing server, because our target group is images. You get that gist? Let's try this out. First, let's make sure that our instances are behaving as expected. So let's go back to the instances. Now here we can see that the load balancer has been provisioned and the state is active. Let's go back to the instances. Click on image processing server 1 and just check its DNS. So it is showing the home page of the image processing server 1, and if you check its images.html, it is showing the message as expected. So we can safely assume that our other processing servers are behaving as expected. Now let's go back to our load balancers, go to its description and copy its DNS name and open it in a new browser. And you can see that it is going to the home page of the image processing server because it followed the default rule. Now I want you to append the images.html at the end of it. And there you go. The traffic was forwarded to the image processing server 1. Now if you keep on refreshing this URL, the traffic is going to go to only one of these two image processing servers, server 1 or server 2. The traffic will never go to the video processing server. If you change this URL to videos.html, you can see that the traffic is going to only video processing servers 1 and 2. So it is following the rules as expected. Now, if you go back to the home page again, just to make sure, the request is going to the image processing servers, but to the home page. So our application load balancer is behaving as expected. Now let's go back and make one simple change and see if our theory is actually working. Go back to the load balancer, select it, go to the listeners, do view and edit rules, and let's change our default rule. So click on the edit. Now, as I had mentioned that you cannot delete this rule or you cannot have the conditions, changed, but you can change the result. So go back and do edit here. Instead of forwarding the default traffic to target group images, let's forward it to target group videos. Just say update. Go back to the load balancer and just hit refresh because sometimes it takes time for the change to propagate. Okay, now go back to the description or go back to the web page and just refresh the home page. Refresh it. And you can see that the request is going to the home page of the video processing servers rather than image processing servers. Now, one important concept in application load balancer is the support for HTTP listeners and security policy. Application load balancers basically supports HTTP listener that enables the traffic encryption between your load balancer and the clients that initiate the SSL or TLS sessions. To use an HTTPS listener, you must deploy an SSL or TLS server certificate on your load balancer itself. This is called as the SSL offload. So the responsibility of maintaining the SSL certificate lies with the load balancer itself rather than individual EC2 instances or the target. The load balancer uses this certificate to terminate that connection and then decrypt the request from the client before sending them to the targets. The elastic load balancing uses a secure socket layer, that is SSL negotiation configuration, that is known as security policy, which is just a combination of protocols and ciphers to negotiate the SSL connections between the client and the load balancer. The protocol establishes a secure connection between a client and a server and ensures that all the data that is passed between them is private. A cipher is basically an encryption algorithm that uses the encryption keys to create a coded message. The protocols use several ciphers to encrypt the data over the internet, and during the connection negotiation process, the client and the load balancer present a list of ciphers and protocols that they each support in order of their preferences. This is just an information about the security which you need to just keep in mind. It may or may not appear on the exam, but it is important for you to understand. The application load balancer do not support SSL renegotiation. Finally, just keep in mind that the application load balancer uses X509 certificate as the SSL certificate.